last talk to mean the discussion section will be very short, but now Jack and I, and Alexander, if he's still on the line, will field any questions about astrophysics from the moon that you have. Thanks.
That's all. We can make stuff up.
Yeah.
Alex, are you there?
Yes.
Very good.
Yes, I am here. Yeah.
So Addie Dove has a question. Of course she does. She's here to help out.
I'm here for you. Addie Dove, University of Central Florida. So you have some mission concepts that involve putting radio arrays on the far side of the moon and in different places. What other instrumentation do you see that might be beneficial for you that you've maybe heard other people propose in terms of characterizing the environment in which you want to put down your arrays? And what do you see your platforms as being beneficial to others who might want to put an additional instrument on if you have additional power or space on your spacecraft?
Right, yeah, those are all good questions, I think. We are a bit sensitive to some of the environment on the moon. So for example, with an array that we would like to put down or individual telescopes, one of the things we'd like to know is the characteristics, some of the electrical properties, the electrical skin depth of the subsurface layers, because there's a certain amount of reflection of the cosmic signals off of the subsurface layers and up back into the telescope that can create some systematics. So if we know what the characteristics of the soil underneath, that would be very helpful. So wherever we site the low frequency telescope, we would like to be able to do a survey of the subsurface conditions as one example. The other thing with the radio telescopes might be of use is we can also serve, particularly at lower frequencies below a megahertz, to do some ionospheric sounding, kind of a classic method that's used for the Earth. Only here, with the very thin ionosphere that you have with the moon, we can measure the column density of electrons fairly accurately in bulk. So it would be a complementary method to what others are doing as well. So those are a couple of examples in which we would do some interaction potentially with the environment.
Thank you all for your talks. I was curious, this is Brad Bailey, Survey. I was curious about the deployment of the Mylar film and whether you've thought about any other type of deployment. And Jack, you look like someone who did a lot of toilet papering back in your day. Is there a chance for having a static lander where you just chuck these things out and have a little star pattern from just like a projectile deployment method?
Yeah, that's actually a good question, Brad. It's surprising we're getting a good question from you, but in general, no. It's a good question because we want to look at different methodologies. I mean, we came up with the Kapton idea almost a decade ago now, and it seemed like an easy way to deploy. But there are some issues associated with actually embedding the metallic dipole antennas onto the Kapton. And so certainly initially for a prototype array, putting individual dipoles down. So what we're doing right now as part of our NEST team is we're studying different antenna configurations, designs, and our plan for this year is to settle on a particular antenna, maybe utilizing some of the results from some of the ground-based arrays and making them smaller and more compact. But I think we're going in the direction of probably individual dipoles for at least an initial prototype array.
Thanks.
Brian Day from Survey, one of Brad's unfortunate colleagues. What do you see necessary in terms of steps and mitigation measures as we start seeing this planned activity in cislunar space in order to keep this a radio quiet environment?
Yeah, that's another good question, Brian. It's one that we've talked a good deal to HEO about. Part of our study that we're going to be doing on this DAPR configuration, one of the things we're looking at is the prospect of actually putting DAPR on the gateway. And so one of the things we'd like to do is to really understand the electromagnetic environment of the gateway. So we're collaborating with Jason Cruzan and his team and some of the engineering help that they're going to provide to really model and see what that environment looks like. So both on the gateway itself, but also if you're on the surface, how much electromagnetic radiation at these low frequencies is going to be produced. So we're not talking about communications here, because communications are all going to be at much higher frequencies. That's not going to be the problem. It's leakage from computers, from other electronics, and that stuff is broadband, and it radiates out. Having the gateway at a fairly high orbit away from the moon most of the time is actually going to be helpful. But that needs to be investigated, because the signals we are looking for are extremely low level. And so it wouldn't take much to contaminate the environment of the far side, and then we'd really be up the creek without a paddle. Because there's really no other good place in the inner solar system to do these observations. So it's a really good question. NASA and the international community are sensitive to this to some extent, but we need to continue to push this as part of requirements also for the gateway. Can we do some amount of shielding? I mean, the first order, you can just put a Faraday cage within the inner walls of the gateway. That will eliminate some of the radiation. This is just chicken wire that we're talking about at these frequencies. But leakage can go out through individual cracks or seals that are not perfect.
Yeah, and I guess when you're dealing with the gateway, it's a fairly easy, limited situation. But when we start talking about the type of commercial expansion that people are envisioning, I mean, you can be a pretty tough cop, but
Right.
how is this going to be enforced?
That's right. So the answer is we need to do these experiments on the far side of the moon before it's too polluted. Because inevitably, as developments occur, it will get tougher and tougher to police that. And particularly individual companies and other countries as well may not be as cooperative. Yeah, so it's a good point.
Sumon, Ramaiah from University of Southern California. So you were saying before any developments happen that pollute the thing, we need to go far side. But since NASA is collaborating with other companies, you have to give an incentive for them to invest their money and take some risk, some amount of risk from their side. What would be that incentive for them that you think should be intriguing for them?
Yeah, I mean, just to get to the far side, there's certainly a lot of scientific reason to be going to the South Pole Lake and Basin, because in the basin you have some really precious geological assets that you would like to be able to sample, but you also have access to some of these permanently shadowed craters where water may be. And from a commercial perspective, what I've heard from companies that we've talked to is, the idea of being able to mine water from the moon is attractive, although we're a very long way from having said that to some actual technology to turn water into rocket fuel or other uses. But I think from a commercial perspective, that could be a lure to the far side and specifically to the Aiken Basin.
Okay, just another question. For the power requirements and the temperature, some of them has to be maintained, like the telescope, some have to be maintained at a certain temperature to gather as much information. So how is that being addressed? What is the power requirements that you're saying? What are the arrangements that you think is more feasible without any already settlement there? You are doing for the first time, so setting up everything will have very, very high initial costs. So
Yeah,
what is
you,
your
you, you raised some good questions. The one good thing, these telescopes are very simple. And so they really don't have any requirements for cooling or heating. Micrometeorite bombardment is not going to affect things very much, or radiation. But where the day to nighttime temperature variations come in is maintaining the electronics and the computer technology. So how do we keep these things warm enough? And really for the kind of signals that Jordan was talking about, for cosmic dawn and dark ages, we really want to operate at night when the temperatures are low. That's not a problem, but it's when you switch from night to day. And so there are, like many other experiments you'd like to do during the nighttime on the moon, there's these challenges.
Okay, thanks.
So the Chinese launched the Chang'e 4 CubeSat L2, and I believe that has some Dutch radio science experiments on it. Are you very familiar with what they're doing? It's something you could mention, whether there's any similarity to what's been discussed here, and also do we know what the RF noise is going to be from that comm relay?
Yeah, Ben, I can give you a little insight into that because Heino Falke from the Netherlands is the principal investigator from the Netherlands side on that experiment, and he's a member of our NES survey team, and we have a collaboration also, and going to be looking at some of those data that come back. So there's good news and bad news on that. The good news is they're very quickly were able to prototype, design, and develop an instrument to put up on that communication satellite in under 2 years. The bad news is they have no idea of what the radio environment is like on the satellite. No information was provided by the Chinese on the characteristic of the satellite. And you can imagine that's not, that's going to be very challenging. So they're going to have to discover that in real time. And we suspect that could be pretty bad. But how broadband is it, and are there some gaps in there? There may very well be some gaps where they can operate. And that will almost surely be the dominant noise. They're also, being at L2, they have full exposure to the Earth, and so shortwave radio that breaks through the ionosphere is going to be a problem. We know that from wind waves experiments and data that's currently available from space. So there's a lot of radio frequency interference that's going to come from the Earth. So, I mean, their hope is really not to, well, it would be a hope, but they're realistic in realizing they don't have a prayer to do the cosmic dawn and the dark ages, but being able to map the radio frequency environments in the vicinity of the moon at L2, and maybe seeing a few solar bursts, solar flares. But once again, unfortunately, we're at solar minimum for this experiment, so there's not many that are taking place. But it's something. We're getting something up there. We have not had a low frequency antenna in orbit of the moon since 1972, which was the RAE-2 experiment that NASA flew, which resulted in the discovery of the auroral kilometric radiation originally.
Any last questions? Okay, well, if not, thank you everyone for coming.
Thanks.